Hi viewers of Electronics Class Tanzania, welcome again to your favorite lesson of electronics. Our lesson today will be about power supply. We are going to learn about the principles of a power supply, also the circuits, the components, and eventually how it operates. Hello viewers, again we are in a power supply. Power supply can be shown how it works in three stages. The first stage is to rectify. We are aware that in a power supply, the input is AC, and what we intended to get at the end is DC. DC. Input is AC. So first stage is rectification. And the next stage is filtering. The signals which are input is like this, is sine wave input. And after rectification, we'll get something like this one. And when we do filtering, we get a smooth output. And then we have a regulator which guarantee us to get the voltage we intend to get. In a rectify, in the rectifications, we take a look at the bridge rectifier. This is a circuit of a full wave voltage double circuit. Here is the diodes. We have D1, diode 1, we have diode 2, we have capacitor 1, we have capacitor 2. What the diode works here in a bridge circuit is to cut the sine waves so as to get the linear DC supply. This is the circuit of a diode, and what diode is working is that it allows the wave, the positive one, to pass through, which we call a forward bias. Forward bias. In a forward bias, the circuit like this, it works like a short circuit. And here we get 0.7 volts. It will short circuit in a forward bias. But in a reverse, when the sine wave in reverse direction, this is positive and negative, the diode will tend to be like open circuit. Will be open circuit. So there will be no flow of voltage at the end. So what we get at the end is like this one. We'll get positive will pass, but negative will not pass. Then we'll have the positive will pass. We'll get something like this one. This is also as a rectification by using a single diode. We continue with power supply. Let's take a look of how diode works. First, the definition of a diode. Yeah, a diode is a semiconductor device with certain properties. The first property is when it's the forward bias. This is the first property. It looks like short circuit. So when we forward the diode, it looks like short circuit. Then we'll have drop 0.7 volts. It's like short circuit, and then it will conduct. But when it's reverse biased, it will be like open circuit. You see There's nothing will flow. In a power supply, we'll come across terms like root mean squares values and peak values. The formula for peak voltage is to take root mean square values, you divide by 0.707. For example, you have 15 volt root mean square values, and you want to get peak voltage, you divide by 0.707. For instance, also if you have 12 voltage root mean square values, you want to get peak voltage, then you divide 12 by 0.707, then you get 17 voltage peak square values. This one is a full wave double circuit. It's a full wave rectifier double circuit. So here we have source. This is AC source, AC. So when it's forward, when we have our input here, yes, AC input, when it is forward, we are talking about this region, the positive one. So here we have forward, positive, negative. But here will be, this will be forward, then it will be like a short circuit. 0.7 volts, forward bars. But here, forward, but here it will be, it will be open. Here it will be open circuit. It will open. So if here it is open, then the circuit will look like our current will flow this side, will come this way, will charge this capacitor, and then it will come this direction. This is how our current will flow. So our circuit will look like this one. This will be a diode short circuit, 0.7 volts. Then we'll have our capacitor here. This is our capacitor, positive, negative, will charge. Let's say we'll charge up to 20 volts. This is our capacitor, then we'll come again here. So this is our circuit, what will look like when we are in a forward bias. So when we are again in a reverse direction, here will reverse, therefore here will open, therefore if this will open, here will be open circuit, open, then our current will flow this way, come this direction, and then here will be short circuit, and then we come again back and here. So the capacitor will be charged in a negative. Let's say we have 20 volts here, but in negative, because we have negative here. So this is how our our full wave double circuit will look like. So the output sine wave, what will look like will be like this one. This is input sine wave, but the output will be like this one. We'll have this one, and again we'll have this one. Yeah, this will look like this one. So when we measure across the capacitors, we'll get the sine wave like this one. When we take a look at your oscilloscope, positive, negative, we'll see sine waves will look like this one. We are continuing with the power supply issues. Here we have a circuit of a regulator. In a power supply, we have a regulator, and this is a basic circuit of a regulator, which comprises of we call op-amp. Op-amp is the operational amplifier, and Op-amp is this one, operation amplifier. We have a transistor here, and also we have a Zener diode here. This Zener diode is acting like a voltage reference. The circuit here with the values intend to have 5 volts as a reference voltage to be 3 times. That's why we have 15 volts here as the output. So our reference is 5 voltage reference. So the op-amp is getting the feedback, and then this Zener diode is a reference voltage, and we get through R2. This is R1, R2. Yeah. Through R2, we have 5 volts, and here we have 10 volts in R1, so we have the output of 15 volts. So this is a circuit of a regulator by using op-amp. Again, let's just take a look of half-wave rectifier, simple circuit of half-wave rectifier. In a half-wave rectifier, what you will see here is ripples, like that one. This is a ripple voltage is this one. This is a ripple, and the formula is this one. This is a frequency of a capacitor, frequency in here. And the frequency in Tanzania is 50 Hz. Our frequency is 50 Hz. That's our frequency. This is RL, it's a load resistor, and this is a diode, it's a D. Yeah. So the formula of a ripple is like this one. This is current, a DC current over frequency across the capacitor, which is a 50, and this is a voltage ripple, our ripple voltage. So the ripple voltage will much depends on the size of the capacitor. The size of a ripple voltage will be proportionally to the size of the much depend on the size of the capacitor. So also our allowable ripple voltage is 2 volts. If you want to have a 15, let's say 15 voltage, so ripple is 2 voltage, so yeah, our design will be on 17 volts to accommodate the ripple of 2 voltage. So this is how op-amp regulator works in a power system. Hello viewers of Electronics Class Tanzania, let's take a look of power supply. I have here a power supply which have AC input. Can take a look of 110 volts stroke 220 volts, 50 to 60 Hz. It depends on the country, but here in Tanzania our voltage is 220 volts, and the output is the DC output, which is 12 volts, 10 ampere hour. So this is a power supply, and here we have a switch. This switch is for 220 volts and 110 volts. So in Tanzania we are using 220 volts as mains from TANESCO supply. So we put our switch in 220 volts, and then here we have our output. We have 1, 2, 3. How many? 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6. We have 6 output, but of 12 volts. And in here, this is our power supply. We have a capacitor. These are capacitors. We have transformer. This is our transformer. Also, this is a secondary transformer. But we also can see we have diodes here. This is a rectifier circuit. 1, 2, 3, 4. The full wave bridge rectifier, because we have seen here we have 4 diodes. We have resistors. This is resistors. We have transistors. We have integrated circuit here. This is a regulator. We have potentiometers. These are potentiometers. And also we have this small capacitors. This is a bigger one, but these are small capacitors. Also here we have diodes and diodes according to the circuits. So Today I just wanted to show you the components of a power circuit, components of a power supply. Hello viewers, we have learned today about power supply, the circuit, the principles, and how it operates. And the next lesson also will be about power supply. We'll go on to the much details so we can know exactly what the power supply is built from, and the physics behind it, the architect from it, so anyone can be able to have or build his or her own power supply. So don't miss the next lesson, and don't forget to like, share, and comment. Electronics Class Tanzania. Thank you for watching.